Number 5. In a mathematics class of 10 students, the teacher wanted to determine how a homework grade influenced a student's performance on the subsequent test. The homework grade and subsequent test grade for each student are given in the accompanying table. So the first thing I want to do is add a list and spreadsheet, name my columns. Now, these both say grade. So if I just said grade, it wouldn't make any sense. So I'm going to call the first one homework and the second one test because they're both grades. Now I want to input my data into the calculator. Now, once my data is in the calculator, I always go to cell C, number 1. So column C, row 1. And here, I'm going to run a linear regression. So we've done one variable statistics before. A linear regression is very similar. Menu, statistics, stat calculation. Now at the top is a one variable statistic, but I want number 3. I want a linear regression in mx plus b form. Now I can name my x list homework. I name my y list test, and I say okay. Now, the information I get from this is I get my slope, 0.834, and I get my b, 14.649. And so that's what I want to type over here. So 0.83, and I'm going to keep the first 4. And for the y-intercept, I'm going to type 14.64, and I need the 9. Because remember, we're rounding to 2 decimal places for both of these. So when I talk about the slope, the number in question, the only digit I care about is that 3. Everything else is already locked. So I know I've got a 0.8. And now I look to the 4. Since 4 is part of the 4 or less category, then I let it rest and I keep the 3. So my slope in this case is 0.83. Now, when I go to the B, I've got 14.6. Go ahead and type that because that's not changing in any way. Now I have the 4. The 9 is the other category. That's the 5 or more raise the score. So that 9 says we're going to make that 4 a 5. So that's my B. And now, the fun thing about using the TI Inspire graphing calculator is I already have my regression equation. Y equals our slope, 0.83, times x plus 14.65. Now, when I look at my R value in this case, the R is 0.961. So, again, the number in question is just the 6. I'm rounding to 2 decimal places. So I've already got the 0 there. The 9 stays, of course. And then this 1 tells us not to do anything to the 6 either, so it's 0.96. That's the R value for this equation. And if you remember, the R value is kind of like a grade on a test. If you got a 96 on a test, you should be kind of happy. That's not a bad grade at all. That's pretty good. So now let's go over and add a new page to our document. So Control Doc, and this time we're going to add a data stats page. Down here, our X coordinate is homework. Over here, our Y coordinate is the test grade. And that's what all our data points look like. Now, the one downside about the Inspire is we don't get to label each one of the dots like we did in Desmos. That's the only downside. I do like having my axes labeled, though. I think that's better for us. Now, I want my linear regression equation. So, menu, analyze, I want to plot a function. My function is 0.83x plus 14.65. And that's the picture that I want to take and put in my document. So I'll make this full size. And stretch to fit. Now, the next detail is there's a little blurb at the bottom. A new student comes to class and has a homework grade of 78. Based on the equation, what would the teacher predict for the test? So here, we're going to use this equation and put in 78 for the grade to find out what the student might get on the test. So we go to our graphing calculator and we add another page. And this time I want a calculator page. So I take this equation, I put it in my graphing calculator, but instead of an X, I'm going to put in the 78 that the student got on the homework grade and determine I would expect that student to get a 90, 79 as their test grade. So for this problem, we practice using the TI Inspire graphing calculator to run linear regression, write our equation of a linear regression, and then interpolate a data point that would be on this graph. So if you think about, if I go over here to 78 on my x-axis and draw a line up and over, I should get to 79 and change on the y. And that's question number 5.